All right, so we're gonna dive into talking a little bit about IVT. So I'd like to start with Adi here. There has been a great deal, and I think over the last couple of years in particular, but I'm starting to get there's more traction and more attention, I think, being focused on the innovations happening in the academic realm, right? So I'd really like to pick your brain. What has been some of the research that's caught your eye, outside of the work you're doing, because we're going to dig into that as well. But what's caught your attention in terms of innovation on the IVT front? And I would say in particular, as it relates to some of the analytical innovations that we're using to really understand the kinetics, right, of our IVT reaction.
All right. So just to give a primer, right? So if we know how the reaction is proceeding, we have an insight into knowing if it's going the way we want it, or if the reaction is creating or synthesizing something that we don't want, like impurities that we don't want, right? And the problem right now is there's no way to actually monitor that with the current set of tools that we have. That's something that we face, and so what we in an academic, like the first step to understand kinetics would be, you just analyze your IVT at different stages. It could be a time series analysis. So you just stop your IVTs at different stages and then just check how much of your product has been synthesized, right? Now, again, the problem is in such a scenario, you need a better tool to differentiate your product from your substrate, because most of the time what happens is you're reliant on UV absorbance-based techniques for getting your yield data, right? Now that's not good if both your substrate and your product is giving some sort of signal at that stage.
Okay.
Right. So that's the main problem that we have faced. So the best option that you can think of is, okay, let's just separate the product from the substrate, which is, you take the IVT reaction mixture, you separate it, you just take the product after some sort of purification and get your numbers, right? Now, if there is a method that can bypass that purification method, that would be the best case scenario. So as far as I've seen so far, there are newer techniques that are coming up. So I've seen people try Raman spectroscopy for this. I've seen IR methods being used to understand the kinetics. So basically, even without any sort of processing of your reaction mixture, you're able to know how much of your product is being synthesized and how much of your substrate is being depleted. And depending on that, if your goal is to go for a fed batch reaction, you could add your substrate as your substrate is being depleted, right? So all of those things. At even wilder stage, I would say that if you can detect impurities like dsRNA, which is, again, I don't think that's possible yet, but if that's possible, that would be a game changer. So yeah, and there are groups which are doing trying to do this particular techniques, or trying to incorporate these techniques to understand the kinetics real time, so that you can give a feedback loop and then control the overall process. So,
Okay. So there is a lot of ongoing work here. I know you've focused quite a bit, yourself on trying to figure out sort of getting the real-time analytics, right? And you and your colleagues have done a number of articles for advancing RNA. I think I've shared at least one or two of them, focusing on the importance of process analytical technologies, right, to really kind of incorporate in and get real-time monitoring of our manufacturing processes. But, one of the things that I think tends to be stated quite loudly is that those technologies just leave a little bit to be desired, right? The legacy technologies. So can you kind of walk us through where you're seeing some of the current shortcomings, with these PAT technologies, and what steps need to be taken to better implement them in the IVT world?
Legacy PAT, we are borrowing it from other mature modalities, right? So again, it wasn't designed specifically for large-scale synthesis of nucleic acid in an enzymatic process. So the problem again becomes that we are using tools that were never meant to be used in this particular process. So you can tweak it and get and use it as a proxy sensor. So for example, you can use some of the legacy PAT and kind of try to get certain variables from the system, right? And try to estimate based on those if your reaction is proceeding the way you want it to. So, for example, if you could measure the pH of your reaction system and then somehow equate that with the NTPs getting utilized for your RNA, you might have an idea on how the reaction is proceeding. Again, it's just one of the options. It's not the overall equation. It's just a tiny bit, right? Yeah. And similarly, you can just combine these different legacy paths that are already there and use the data that these are generating and combine it with a soft sensor to get a better idea of where your system is. Now, we need more extensive work on this. Yeah. Because again, and that's where we are going. Because again, when more people are trying to work on this, you get more solutions. So far, that wasn't the case. So it's going there.
We're starting to get some traction.
Yeah, definitely. Yeah.
Tyler, I'm curious. Have you been watching this space at all? I know in terms of some of the analytical technologies for IVT, trying to make this get better understanding of real time, et cetera. What's catching your eye, if anything?
Yeah, I think that's, I mean, the ultimate goal would be to have in-process monitoring, real-time feedback of all the analytes. I think it is difficult. Hopefully, teams like Audi are, invent amazing things that we can put into our processes that give us that read. I mean, right now, a lot of times we're pulling, samples, especially in the process development stages, pulling samples at time points, throwing them through HPLC methods and being able to read those out, and then really designing our process around that understanding, right? And so I think it's as good as we can get right now. But I think it's something that absolutely, maybe there's also, correlations to things that we can read out, like pH or other things that give us an indication of when we might be running out of NTPs, or we may need to be adding more magnesium or things of that nature. So I think there may be some type of analysis in real time that we can monitor.
Okay. Yeah. April, would you agree? Have you been watching this space?
Well, I think so. With mRNA, what I think about with the process analytical technology is really building the data set. So at my company, Life Edit Therapeutics, we bioengineer a lot of enzymes, and we use mRNA to express them and screen them and things. So this sort of process analytical technology really helps us, hopefully in future, get to a point where we can customize or know going in with a certain type of sequence or motifs and things, how that's going to affect key production parameters. So I think it's not there yet, but this is a key part of using AI to get there. We need to build a data set, and then it's going to be really powerful. So I'm looking forward to as we build that data set.